let's find the automorphisms of this digraph. Now, automorphisms are permutations or bijective functions from the set of vertices to itself in such a way that edges are preserved. So if you have an edge in the domain between two vertices, then like 1, 3 could be mapped maybe to 1, 2, because look, this edge right here can be kind of sent to this edge here. So since there's an edge between these, it could be sent to there. So that's a property that actually has to be satisfied for all edges. Okay, and then it'll be an automorphism. So let's kind of think about what types of permutations would provide that ability here. So, well, for one thing, if we look at this, like 1 is kind of like an initial element of everything because everything kind of comes out of it. So kind of the arrow structure around it has to be maintained. So it doesn't really look like 1 will always be sent to it. So let's see. Yeah, because nothing goes into it, but something always goes into everything else. So therefore, we have 1 will always go to 1. Okay, what about 3? Well, if you look, like there's 2 arrows, like this arrow going out that way, that arrow going out that way. So 3 goes to 5 and 4. 2 goes to 5 and 4. Oh, and see this? It looks like 2 and 3 are really interchangeable in this. So really, you could have, you know, 2 could, you know, 2 could go to 3, 3 could go to 2. Those are interchangeable. You could have something happening kind of like this. In fact, maybe we should move to cycle notation 2, 3. Okay, so we could have something like that. What about 4 and 5? Notice that 4 is connected to both 3 and 2 coming in, and then 5 is connected to these two coming in. So it has kind of like that. They're kind of interchangeable in the basic structure. So really, 4, 5, we could switch those. So really, it looks like we can switch these interchangeably, and we could also do it in tandem. We could switch 2 and 3, and then switch 4 and 5. So switch 2, 3, switch 4, 5, and so we have a cycle type here: 2, 3, 4, 5. Think of those as cycles. Maybe we can get rid of the commas just so we can kind of imagine that, okay, so these are cycles here. Kind of think of it that way. So this is a 2-2 cycle, so you have this cycle and that cycle, so 2 goes to 3, 4 goes to 5, and they go back and forth. So basically, it looks like we have these 3 automorphisms, but we also have an important one we don't want to forget, and that is the identity, meaning do nothing. Okay, that is an automorphism. So it looks like we have 4. These 4 automorphisms actually form a group under composition. A 2, 3 is the inverse with itself. 4, 5 is the inverse with itself. And this guy is the inverse with itself as well. So, but you can compose them together. It's a group under composition. We call it the automorphism group for this particular digraph. Thanks for watching.